So for part A, it says use algebra to solve this equation. And in this equation, I hope you notice that these two I've underlined in purple are like terms. Plus 5 and plus 7 are like terms. And it's in degrees. So a lot of this is really a grade 11 question. In fact, all of this is a grade 11 question except for the general solution and maybe the fact that it goes from 0 to negative 360 instead of 0 to positive 360. So what are we going to do? Well, we'll put our like terms together. If I move the signs to the right-hand side, you see that you would get negative 2 sine x. If I move the 7 over to this side, I'm going to get negative 2 on the right side. If I get the sine by itself, by dividing both sides, I get 1. This is on our axis family. Right? If you think about your unit circle, your pi plate, when is your y-coordinate equal to 1? Right up there. Okay? And this is going to happen to you a fair bit. You're going to write an answer. You might remember you're in degrees. You might write it in radians because you didn't remember. Okay? It is true that x is 90 degrees. But does that fit in our domain that they asked? So one of the things you're going to do is you're probably going to solve like normal and then go, oh, wait a minute. They're asking in 0 to negative 360. That's in this direction. So maybe I put an X through this and say it's actually negative 270 degrees. It says then write the general solution. I'll do that in blue. How do we write a general solution? Well, we take our answer and add 2k pi, but this is in degrees. So instead of 2k pi, does it make sense that we're going to do 360 degrees times k? That would write all of our coterminal angles. And k has to be an integer. Now, if you would look at the bottom of the page, or if you would look, oh yeah, your answers are, if you look at the answer key at the end, you'll see that the textbook did this. Both of those are right answers. Because what does this mean? This is 90 degrees plus everything that's coterminal with it. This says minus 270 degrees plus everything that's coterminal with it. Would you agree that minus 270 is coterminal with 90? This first number, you have options. You could pick, if I added 360 to this, I'd get 450 degrees. I could have written my answer as 450 degrees plus 360 degrees times k. This one is my favorite. Because I always like to go first time around from 0 to 360, or if we're in radians, from 0 to 2 pi. What are my answers between 0 and 2 pi? And then add all the coterminal ones after that. But you can choose any coterminal one. And the textbook used the minus 270 because they said, well, you found the answer in part A, or you found the answer at the beginning to be negative 270, so why don't we use that? Okay. Personally, I prefer the 90. I always like to check everything the first time around and write everything coterminal after that. Okay, part B. Part B, use algebra to determine the general solution of the equation cos 3x equals 1. Then list the roots from negative 2 pi to 0. Do you see that this is a multi-revolution question from yesterday? I'm going to show you two methods for this multi-revolution question. The first method is what we did yesterday. And the second one is a shortcut in this situation because it asked for the general solution first. What we did yesterday would say, if you want a general solution, the instructions we wrote down yesterday was first solve between 0 and 2 pi. And this is in radians. Then write the general solution. Okay? And in a multi-revolution question, if you solve between 0 and 2 pi, multi-revolution is rewrite the domain for 3x first. So we'll do that. We'll say, if we're solving for x between 0 and 2 pi, then as a multi-revolution question, 3x's would be between 0 and 6 pi. Cos x equals 1. Do you see that this is, wrong dot, that's minus 1. Over here. That's the dot we're looking for. Because cos is your x coordinate. In your axes family, that would happen over there.
We're not, that's the wrong,
Cos 3x. Oh, negative 1. Thank you. Negative 1.
we're also looking for, I think it's like negative 2 pi.
I know, but that's part B. That's after. We're doing the general solution first. So in a general solution, solve between 0 and 2 pi. And then add 2k pi to each of those answers. And I'm going to show you two methods for this. Method 1 for the general solution. Method 1 for the general solution is what we did yesterday. So then we solve for 3x. If cos 3x is equal to negative 1, then 3x would equal, well, there it is. First time around the circle, you would get pi. But for 3x, we have to go 3 times around the circle. The second time around the circle, what would this be? 1 there. 3 pi. Third time around the circle, 5 pi. And then x, divide each by 3. Those are our solutions. I'll make a little note here. These are our solutions between 0 and 2 pi. So in a multi-revolution question, you get your domain for 3x. In this case, is 3 times around the circle. You solve for 3x over that domain of 3 times around the circle. Then when you divide by 3, your new solutions are all your solutions between 0 and 2 pi. From here, we can now write the general solution. Take all 3 of your answers. Add 2k pi. Okay, it's an integer. Okay, so if I would describe method 1 for the general solution, I would describe method 1 as we did from 0 to 2 pi first. Then the general solution after. Okay? Method 2 for the general solution. So when a multi-revolution asks you to find the general solution, you have these two methods. Method 2, we do the general solution for 3x first. And then do a general solution for x. Method 2 will come up with a more elegant answer, but it's different than what we've done so far, okay? So we have cos 3x equals -1. If it asked us for a regular general solution, if it was just cos theta equals 1, what would you do? You would say, well, I'm going to solve between 0 and 2 pi. How many times do we have -1 between 0 and 2 pi? Only once. It happens at pi. And so if this was a theta, you would write theta equals pi plus 2k pi. So we're going to write 3x equals pi plus 2k pi, where k is an integer. That's the general solution for 3x. Because there's only one answer between 0 and 2 pi for 3x. That's what it would be. Then the general solution for x is you divide by 3, which means this gets divided by 3 and this gets divided by 3. K is still an integer. A little bit quicker, a little bit more elegant, but you have to understand it from that perspective. So when you have a general solution for a multi-revolution question, you have two options. You can, the normal way that we've done it all the way along, is solve between 0 and 2 pi first, then take all of your answers and add 2k pi. The second way is finding the general solution for 3x, divide everything by 3 and look at the answers. And the next thing I'm going to do is I'm going to show you a picture with the unit circle to show why these are the same. Okay? So if I take out my unit circle here, and in purple, I do the answers I got from the first one. The answers I got from the first one were pi over 3, which would be this line right there, right? Pi, which would be this dot right here. And 5 pi over 3, which would be in quadrant 4, would be this dot right there. And solution number 1 says take pi over 3, and anytime you add 2 pi to that, you would be coterminal with pi over 3. So I do all the coterminal ones with pi over 3. Then I took pi, and I wrote everything coterminal with pi. And then I take 5 pi over 3 down there and do everything coterminal with that, and that will be all my answers forever. In the second solution only has, and I'll show it in orange, it only has this one. But then how much does it jump? It doesn't jump all the way around. This doesn't mean everything coterminal with pi over 3. This says take pi over 3 and then jump 2 pi over 3 as many times as you want. Can you see that if I took one jump of 2 pi over 3, I would get here? Another jump of 2 pi over 3 would get me there. Another jump of 2 pi over 3 would get me back to where I started from. 3 jumps of 2 pi over 3 is 2 pi. And so if I do smaller jumps, I would hit all 3 of those answers. And if I did that forever, I would get the same result as the first one. So hopefully that visual shows why they're the same. Mathematicians would say the second answer looks more elegant because it's shorter. It's more compact. You are able to write it either way. It's fine if you did, like, for a lot of us, this makes a lot of sense because this is an answer and everything coterminal with it. An answer and everything coterminal with it. An answer and everything coterminal with it. This one is an answer plus a bunch of different answers that are jumps, but not necessarily coterminal. But it includes them all because we're doing smaller jumps. And because the spacing in between the three answers is exactly the same, we can jump by that smaller space, jump by that smaller space, jump by that smaller space, and get all the same answers both ways. So on your quiz review, you will see in the answer side, I have both methods as a solution. If I hadn't shown you method 2, you'd probably do some of those questions on the quiz review and be like, how the heck did they get this other answer? And it would be confusing. So that is an explanation why I have those two solutions, and both are possible. Okay. Now we're not done yet, because the question just also said, after you've done the general solution, list the roots. So we're going to do that now. We're going to list the roots in negative 2 pi less than x less than or equal to 0. Oh, and they don't have an equal sign. Not that it's going to matter in this situation, but sometimes it does. They didn't include that equal sign there. I double check my domain for little details. And it's nice that I've already drawn the picture. Can you see from negative 2 pi to 0, that's once around in the negative direction, we're going to have one answer here, one answer there, and one answer there. And since I've drawn it, I think it's really easy to see. These are all going to be part of my pi over 3 family. The one in quadrant 4 is going to be negative pi over 3. The one at pi is going to be negative pi going in the opposite direction. And the one in quadrant 1 is like going 4 quadrants. So I take my answer in quadrant 4 for pi over 3, which is 5 pi over 3, and that'll be negative as well. So doing the first part and drawing the picture really helps me see the answer for listing it between negative 2 pi and 0. All right, circle questions 4, 8, and 9.